Hey guys, it's Kyler, and today we're going to talk about DNA replication. Now, DNA replication takes place in late S phase of interphase in a cell. This is to get ready for mitosis or meiosis, depending on if the cell is somatic or if it is a sex cell in eukaryotes, or sometimes in prokaryotes when they just need the one cell, they need new DNA so they can replicate themselves. So this is what we will be getting into today. Hope you enjoy. DNA follows a semi-conservative method of replication, which means half of the two new strands will be new in itself and half of it will be old. And we'll talk about why that happens here in a minute. The first step to DNA replication is when DNA unwinds from the histone proteins. To condense into the chromosomes, the chromosome pairs, for each cell in an organism, DNA has to wrap very tightly around histone proteins to give it this shape. So it must first unwind from these. The second step is that a helicase enzyme will bind to the DNA. So DNA is wrapped up in the double helix shape, and it must get unwrapped so that the DNA replication can properly happen. So the enzyme will bind itself to the DNA and start to unravel those strands from each other. Basically, what it's doing is it's breaking the covalent bonds between the nitrogenous bases. The third step happens when RNA primer, so these two little dots here, the RNA primer, it will read the DNA strands. It will then gather the appropriate enzymes and molecules so that the opposite strand of the two old strands can be made. The fourth step of DNA replication is when DNA polymerase, is made and it joins on both strands of the DNA or the new DNA. So we have one up here and one down here. What happens is that replication can only happen from the 5 to the 3 end of DNA. And as this side, so we have it up here, so the replication is going up this way. Now the polymerase is right here, so the replication is coming down. And you can see because there's these no strands of DNA that are being made in the direction of the arrows. So the polymerase, what it will do is it will gather the molecules that the primer got and actually put them together, the correct nucleotides together, but it doesn't bind the two DNA strands yet. That's for our next step. The DNA ligase pulls the strands together, making two strands of identical DNA. As you can see here, our covalent bonds happen between the two strands thanks to the DNA ligase. And so now we have the two identical strands of DNA because we had one old and one new. And since DNA will be inverse of each other for the sides, we will have two new strands. Our last step is when telomerase adds a short intron cap with unnecessary DNA that won't code for genes, but its purpose is to protect any exon DNA or the green DNA that's there so that it isn't damaged or lost. It's a higher chance that the cap will be lost than the good DNA, which is good for the cell and its function overall. And now the two strands are separate from each other. They're wrapped around back into that double helix, and we have two new strands with the old and new, making that semi-conservative approach. And that is how DNA replicates. Okay, so we just went through a lot of information there, and I hope it didn't confuse you too much. It's a pretty simple process with its 6 steps once you get to know it. But there is a difference on how the whole process works between prokaryotes or single-celled organisms and eukaryotes, or multicelled organisms. And prokaryotes, they have circular DNA. So what happens is the replication has to start all in one place. And the DNA or the polymerase, they will actually go around the circle in opposite directions with the 5 and 3 ends, and DNA replication will take place like that. Now in eukaryotes, the DNA replication can actually start in hundreds or even thousands of places because it is in a linear direction, not circular. So when the process starts to take place, you could have, if you imagine, you have your DNA wrapped up, you have one end here, and everything between this is replicated, and not necessarily anything outside of that space is, except for an S phase when we need all the DNA replicated, then obviously we're going to have that go all the way through. So that's what the difference is between what happens in prokaryotes and what happens in eukaryotes. And also, a little advantage for prokaryotes, since they have a set starting and stopping point, they're much less likely to have an accident when it comes to bonding and pairing than eukaryotes. Even though eukaryotes have about 10 to the power 7th chance of that happening, of even making one mistake with the nucleotide, it is still more likely than it happening in a prokaryote. So that is all that we have for today. But a little fun fact before you go, if we wanted to instead make RNA instead of DNA, because we wanted to have transcription take place, what would happen then is an RNA polymerase would come in instead of a DNA polymerase and separate that all RNA out from the DNA. So that's all that we have today, like I said, and I really hope you enjoyed this video. It's really not too complicated of a process if you can get those 6 steps down and understood. I hope you enjoyed it, and have a great day.